Sun is the source of life on our planet Earth, but harmful components of sunlight such as ultraviolet B and C or UV B and C can cause skin damage and even affect our DNA. Like a sunscreen for Earth, the ozone layer or the ozone shield, which is 90% of the stratosphere, absorbs most of the ultraviolet radiation coming from the sun and thereby protects the living beings below. Ozone molecule is made up of 3 oxygen atoms. Ozone is a colorless gas. It is very active and it reacts readily with many substances. So, ozone laying nearest to the Earth's surface, that is in troposphere, is bad for us. But it absorbs the harmful UV radiations coming from the sun. So, the one in the stratosphere that absorbs UV radiations is a lifesaver. In 1974, these 2 scientists proposed that there were a group of gases being emitted into our atmosphere that could cause harm on our ozone layer. They are chlorofluorocarbons or CFCs. They had a very hard time because CFCs were used in a variety of products at that time, like air conditioners, refrigerators, aerosol spray cans, etc. But later, they received Nobel Prize in Chemistry in the year 1995. In 1985, these 3 gentlemen, Farmer, Gardner and Franklin, measured total amount of ozone between Earth's surface and space over Halley's Station in Antarctica. They saw that the level of ozone was decreasing very fast over the years. The ozone layer is not a single layer of pure ozone. Let's find out how much ozone there would be in a column if we squeezed it into a single layer. At 273 Kelvin temperature and 1 atmosphere pressure, 1 Dobson unit gives a layer of ozone 10 micrometer thick. In this unit, the average amount of ozone in our atmosphere is roughly 300 Dobson units, equivalent to a layer of 3 millimeter thickness. An image of the hole was created, which was over Antarctica. The red and yellow colors show very low ozone. That we can see is a large area. There were a lot of anxieties and discussions in the international community, and in 1987 there was an international agreement called the Montreal Protocol, which contained regulations on the production of CFCs. These CFCs are inert and non-toxic, and these characteristics made them very popular and well suited for applications in refrigerator cans, etc. But these same characteristics make them a danger to life on Earth because some of them have a life of 50 to 100 years. So, even though the Montreal Protocol came into light, the effect of the ban on CFCs was very slow, as we can see from this picture. The whole area was the largest in the year 2000, but then it began to decrease. NASA and other agencies show a 20% decrease in ozone layer depletion. It is predicted that the hole will completely heal by 2050. But now there's a new problem. The world slowly shifted to HFC, hydrofluorocarbons, instead of CFC, chlorofluorocarbons, after the Montreal Protocol. These are greenhouse gases. It can cause global warming 10 times more effectively than carbon dioxide, which is our main villain. And they are increasing in the atmosphere. Even though there seems to be developments that makes us anxious, like formation of a new hole over the Arctic and delay in recovery of the hole over the Antarctic region, things are far better now. The Arctic hole has healed and the Antarctic hole is healing, all thanks to Montreal Protocol. We celebrate World Ozone Day every year on 16th September to commemorate the signing of this Montreal Protocol. It is celebrated to spread awareness among the people about the depletion of ozone layer and search for possible solutions to preserve it. Thank you all.